resistors are connected in parallel. 3, 4 and 6 ohms. 3, 4 ohms. So this is the effective resistance of the entire combination. A uniform wire is modified as a triangle are connected in parallel. Effective resistance is 3.75 ohms. Is the effective resistance when the resistors are connected in parallel. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my yesterday's class, we worked out a few problems from the chapter Electric Current. Hope you followed those problems. You have revised. You have tried to work it out by your own. In my today's session, let us continue with few other problems which are slightly more aggravated in thoughts. Simple, but these are the problems which again continuously appear in the exam. Now, this is one problem which is asked quite a number of times in the examination. The problem reads, there are 3 resistors. 3 resistors of 3 ohms, 4 ohms and 6 ohms. 3 resistorಗಳಿದೆ of 3 ohms, 4 ohms and 6 ohms which are connected in parallel. ಯಾವ ರೀತಿಯಾದಂತ ಕಾಂಬಿನೇಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ? Good. Resistors are connected in parallel. 3, 4 and 6 ohms. That combination, a parallel combination ಇದೆಯಲ್ವಾ, it is connected in series. Further, it is connected in series with a resistance of 1 ohm and a cell of EMF 2 volts and internal resistance 2 ohms. A parallel combination na ಏನು ಮಾಡಿದೀವಿ ನೆಕ್ಸ್ಟ್? ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ. ಯಾವುದಕ್ಕೆ? 1 ohm ರೆಸಿಸ್ಟೆನ್ಸ್ಗೆ ಅದ್ರ ಮೂಲಕ ಸೆಲ್ of EMF 2 volts and internal resistance 2 ohms. I have to find current through the resistances. Now, the first part, what am I going to do here is to construct the circuit diagram. So there are 3 resistors which are connected in parallel. First, I have 3 resistors connected in parallel. ಇದು 3 ohm resistor ಆಗಿರುತ್ತೆ, ಇದು 4 ohm resistor ಆಗಿರುತ್ತೆ, ಇದು 6 ohm resistor ಆಗಿರುತ್ತೆ. Further, the parallel combination is connected to 1 ohm resistor in series. So this parallel combination 3, 4 and 6, they are connected in series to 1 ohm, and further it is connected to a cell. So what is the EMF of this cell? 2 volts. Internal resistance 2 ohms. So the EMF of the cell is 2 volts. Internal resistance is 2 ohms. I assume I1 is the current flowing through 3 ohm resistor. I2 current flowing through the 4 ohm resistor. I3 is the current flowing through the 6 ohm resistor. And I is the main current flowing through the circuit. And according to the problem, I have to calculate I1, I2, I3 current flowing through each resistor. And remember, I will also calculate current flowing through 1 ohms. First, what is that I have to do? I have to find the effective resistance of the parallel combination. The parallel combination ಇದೆಯಲ್ಲ ಅದರ effective resistance ಕಂಡುಹಿಡಿಯಬೇಕು. So that is 1 by Rp is 1 by R1 plus 1 by R2 plus 1 by R3. ಮಾಡಿದೀವಲ್ವಾ parallel combination ಗೆ, if you remember, 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp equals 1 by R1 is 1 by 3 plus 1 by 4 plus 1 by 6, or this is equal to, now 1 divided by 3, 0.33 plus 1 by 4, 0.25 plus 1 divided by 6, 0.166, which is equal to plus 0.25 plus 0.33 is 0.746. This is 1 by Rp, but as I told you, we want Rp. So Rp is 1 divided by 0.746. So this is 1 divided by 0.746, which is 1.34 ohms. ಗೊತ್ತಾಯ್ತಲ್ಲ? ಮತ್ತೆ ಪುನಃ ನೋಡಿ, 1 by 3 is 0.33, 1 divided by 4 is 0.25, 1 divided by 6 is 0.166. So when we add them, we have, again, let us check this calculation, 0.33 plus 0.25 plus 0.166 is 0.746. 1 divided by 0.746 is 1.34. This is the effective resistance when the resistors are connected in parallel. Now, this parallel combination further is connected in series with 1 ohm resistance. Alva, this parallel combination na 1 ohm resistance jote series al connect ಮಾಡಿದೀವಿ. So, R effective is 1.34 plus 1, which is 2.34 ohms. So, this is the effective resistance of the entire combination. First, parallel effective resistance kandidiyodu. Next, that parallel mode is in series with 1 ohm. So, Rp plus 1, 1.34 plus 1, which is 2.34 ohms. Now, I have a cell of EMF 2 volts and internal resistance 2 ohms. With these data, how will I calculate the main current? Good. Wherever there is a cell, the main current is E divided by capital R plus small r. ದಯವಿಟ್ಟು ಈ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Wherever there is EMF, effective external resistance and internal resistance. So I equals 2 divided by, now this is R effective, which is 2.34 plus 2 divided by 4.34, which is, so 2 divided by 4.34, so 0.46 ampere is the current, which is the main current. E divided by R effective plus R, 2 divided by 2.34 plus 2.46. Now, I want the potential for this parallel combination. So, potential for the parallel combination is I into Rp. So, this is 4.46 into, now it is only Rp, 1.34. So, this will be 0.46 into 1.34, which is 0.61 volts. So I know the potential across the parallel combination remains the same. So therefore I1 will be equal to V by R1. This is an assignment for you all. I2 is V by R2. I3 is V by R3. So this is how we calculate what is called as the individual currents. Next one. A uniform wire of resistance 24 ohms. There is a uniform wire. Resistance is 24 ohms. It is bent into 3 parts. ಆ ಯೂನಿಫಾರ್ಮ್ ವೈರ್ನ 3 ಭಾಗಗಳಾಗಿ ಬೆಂಟ್ ಮಾಡಿದ್ದೀವಿ. 3 parts in the ratio 3:2:1. Now the ratio of the resistance across the 3 parts is 3:2:1 to form a triangle. Nodi? Very beautiful. A uniform wire is modified as a triangle. Uniform wire is bent as a triangle. 3 parts ide. Ratio of resistance across the 3 parts is 3:2:1. Cell of EMF 4 volts and internal resistance 2/3 ohms is connected across the lowest of the 3 resistances. A cell is connected across the lowest of the 3 resistances. I have to calculate current in each branch of the circuit. My dear students, here I have just the ratio of the resistances, but I don't know which is the highest resistance or the lowest resistance. That is what I have to calculate first, because the cell is connected across the lowest of the 3 resistances. Now, how do we do? Now, I say we have total resistance is 24 ohms and the ratio is 3:2:1. I assume let X be the unknown resistance. X be the unknown resistance. Therefore, ratio is 3:2:1. ಈ ratio ಕೊಟ್ಟಿದ್ದಾರೆ. And X is the unknown resistance. So 3X plus 2X plus X. This turns out to be 24. X unknown resistance, 3X plus 2X plus X is 24, or X, the unknown resistance is 4 ohms. So X turns out to be 4 ohms. So what is R1 equal to? 3 into 4, 12 ohms. R2 equals 2 into 4, 8 ohms. R3 equals 1 into 4, 4 ohms. So very clearly now I come to know 4 ohms is the lowest resistance. So we draw the circuit for this. Triangle shape, 3 parts. So here 12 ohms and 8 ohms connected in series, 4 ohms. Now across this 4 ohms, which is the lowest, we are connecting the cell. Now the EMF of this cell is 4 volts. Internal resistance is 2/3 ohms. So E is 4 volts internal resistance is 2 by 3 ohms. I have to find the current in each branch. Again, main current, this is I1, this is I2. To begin with, students, 12 ohms and 8 ohms are connected in series. So RS is 12 plus 8, which is 20 ohms. So the effective resistance here, 12 plus 8 is 20. And this 20 is connected in parallel with 4. So 1 by Rp is 1 by 20 plus 1 by 4. So this is equal to 1 divided by 20, which is 0.05 plus 1 divided by 4, which is 0.25. So this is plus 0.05, 0.3. So Rp is 1 divided by 0.3, which is 1 divided by 0.3, 3.33 ohms. So the effective resistance across the combination of resistors is 3.33 ohms. Now again, main current. So I equals E divided by Rp plus R4 divided by 3.33 plus small r is 2 by 3. So 2 divided by 3 is 0.66. This is, so 0.66 plus 3.33 is 3.99, nearly 4. So 4 divided by 3.99. So this is 1 ampere. So the main current which flows through this circuit is 1 ampere. Now first I will find out I1, which is the current in the first branch. So how will I find out I1? I have already given you the formula. Branch current is main current into resistance of other branch divided by sum of resistances. You should remember this. So it is main current into resistance of the other branch divided by sum of resistances. So main current I, so how much is I? 1. I into resistance of the other branch 4. You are calculating I1. So main current into resistance of the other branch divided by sum of the resistances. Here the effective resistance is 20 plus 4. So this is 4 because I is 1 divided by 24. So 4 divided by 24, which is 0.166. Similarly, calculate I2, which is an assignment for you all. Next, This has to be worked out as an assignment. This question is for you all. Please see that. Take a pen, pencil and do workout. When two resistances are connected in series to a cell of EMF 2 volts and negligible internal resistance, current of 2 by 5 ampere flows in the circuit. When the resistances are connected in parallel, the main current is 5 by 3 amperes. Calculate the resistances. This will be an assignment for you all. Now, the next one. A 220 volt 100 watt bulb. So power is 100 watt. Voltage is 220 volts. Is connected across 100 volts supply. What will be the power consumed? Very simple. We know P is V into I, or from Ohm's law, I is V by R. So, P equals V square by R, from which R is V square by P. So R was V square 220 square by 1000. So this is 220 into 220 divided by 1000, 48.4 ohms. So resistance is known now. You want power, substitute here. So P is 110 square main supply divided by 48.4. So this is 110 into 110 divided by 48.4. 250 watts will be the answer. A simple one. This is actually from an entrance exam. No, this is important. Two coils have an effective resistance of 16 ohms when they are connected in series. Ready? When they are connected in series. So when they are connected in series, RS equals R1 plus R2. So how much is RS in series? It is 16, which is R1 plus R2. I call this equation 1. And when the same two resistors are connected in parallel, effective resistance is 3.75 ohms. So RP is R1 R2 divided by R1 plus R2. So 3.75 equals R1 R2 divided by, how much is R1 plus R2? 16. So R1 R2 equals 16 into 3.75, which is 60, and I call this equation 2. Now I have to calculate R1 and R2 which are the individual resistances, for which I use the equation of biquadratics. R1 minus R2 whole square equals R1 plus R2 whole square minus 4 R1 R2, because I know the value of R1 plus R2 and R1 R2. So 16 square minus 4 times 60, 256 minus 240. So this is 16, or R1 minus R2 is 4. Now, we know R1 plus R2 is 16. R1 minus R2 is 4. So this cancels. 2 times R1 is 20. So R1 is 10 ohms. So we get the value of R1 as 10 ohms. Substitute it either here or in equation 2. You get the value of R2, which is 6 ohms. So my dear students, very clearly you have seen, again, very simple problems. If you are thorough with your calculations, things become fine. We will meet in the next session with few more problems. Until then, thank you.